Hi, everyone. I wanted to take a minute and think a little bit more about our bonding and specifically bonding and polarity and how they relate to each other. Um, so, again, just remember back when we started talking about bonding, I decided to relate everything to Coulomb's law, which I won't take time with again, except to say that it's related to how much charge there is, and then the distance are your two big considerations when you're talking about bonding. Um, so let's take a minute and we'll summarize all the kinds of bonding we have. We can have ionic bonding. So that's where you have A and B. One is positively charged, one is negatively charged. You have a lot of charge. These ions can get right close to each other. So you have high charge with low distance. Okay, so ionic bonds would be the strongest. Next, we have covalent bonds, right, where A is sharing a pair of electrons with B. Okay, so the nucleus of A is attracted to these electrons of B, and the nucleus of B is attracted to the electrons of A. Okay, and we're really going to go from highest strength to lowest strength as we talk about this. Okay, and again, you can have these be shared unequally if the electronegativity of B is greater than A. Then you'll get, right, a region of negative charge on one side, a region of positive charge on the other. Okay, and then you can get into dipoles, molecular dipoles, all that stuff we talked about before. All right, and then so these interactions are dipole interactions. Those weird sounds you hear are the tortoise eating his dinner. All right, so again, not as strong as a covalent bond, but still relevant, useful, especially in biological settings. They hold proteins and DNA together. And you can have a special type of dipole if you have an electronegative atom like oxygen or nitrogen with a hydrogen attached. Right, this case here, a fairly electronegative atom attached to nitrogen. This can do a dipole-dipole interaction. Right, and if one of these interacts with another, that's a special type of dipole interaction called a hydrogen bond, because you have a polar hydrogen bonding with a polar electronegative atom. And usually these are oxygen hydrogen or nitrogen hydrogen pairs that are doing this type of hydrogen bond. Okay, so a hydrogen bond is a type of dipole interaction. Okay, and then lastly, and this is true so you have to have certain kinds of atoms here for this to be true. There's one last one that is true in any atom or molecule. Okay, and let's say we have a long molecule, and if we'll say the cloud I'm drawing is the cloud of electron density. When you get two molecules and they have surface area, what you can get is temporary charges, small charges on one side that are complementary to charges that are on another molecule. Okay, so these are called dispersion forces. They're for all molecules, even nonpolar ones. And they're proportional to, that's my little symbol for proportional to, surface area. Okay, so that is all of this surface area is a potential interaction. Now again, this is on the weakest end of our scale here. Okay, so dispersion forces are relatively weak. Okay, right, and then we have to remember two things. Most of what we've been talking about is two molecules interacting. right, where we have A interacting with something maybe that's covalently bound together, these two things. Let's say they're polyatomic ions. All right, but you can also have, if A is big enough, you can have one region of A interacting with another region of A. Let's say you have a polar atom with an attached oxygen, and here you have an oxygen with some lone pairs on it. All right, this is a slightly negative region of high electron density. Here's a slightly positive region. You could get some hydrogen bonding there inside the same molecule. So if you're inside the same molecule, you're intramolecular. Intra means among or within, right? And as opposed to what we were talking about before, which is inter, which means between, intermolecular. Okay. All right, so I'm going to go back and I'm going to go to your problem set and see if I can be more specific help on that problem set.